Today, we're going to be solving the TwoSum problem, the first problem on LeetCode in C++. This problem asks us to find two numbers in an array that add up to a given target value. We'll walk through each solution step by step and understand the logic behind them. Now before we get into the video, if you guys want to see more videos like this, drop a like down below. It helps us out tremendously with the YouTube algorithm, and with that out of the way, let's hop right into it. So the first solution we'll discuss is a brute force approach. Let's take a look at the code. This solution iterates over the array twice, comparing each pair of elements to the target value. Let's break it down. So first, we define a function called TwoSum that takes in a vector of integers, nums, and an integer target. It returns a vector containing the indices of the two numbers that sum up to the target. Inside the function, we store the size of the input array in the variable n. We then start a nested loop. The outer loop iterates from the first element to the second last element, using the variable I as the index. The inner loop starts from I plus 1 and goes until the last element of the array, using the variable j as the index. This ensures that we compare each pair of elements only once, without repetition or redundancy. In each iteration, we check if the sum of nums I and nums j is equal to the target value. If it is, we found our solution. We create a vector containing the indices I and j and return it. If no solution is found after exhausting all possible combinations, we return an empty vector to indicate that no valid pair exists. While the solution works, it has a time complexity of O times n to the second, so that means that the execution time grows quadratically with the size of the input array. Let's move on to a more optimized approach. Our second solution involves using a hash table to improve the time complexity. Here's the code. Or let's run this first. In this solution, we make use of an unordered map, nummap, to store the numbers as keys and their indices as values. Let's understand the code in detail. Similar to the previous solution, we define the TwoSum function that takes in the vector nums and the target value. We create an unordered map called nummap, which will serve as our hash table to store the numbers and their indices. We calculate the size of the input array and store it in the variable n. The first loop iterates over the elements of nums. For each element, we assign the current index I as the value of the corresponding to the key nums I in the hash table. This step effectively builds the hash table associating each number with its index for easy retrieval later. Next, we start another loop to find the complement of each number. The complement is calculated as target minus nums of I, where I represents the current index. Inside this loop, we check if the complement exists in the hash table using the count function. Additionally, we ensure that the complement's index is not the same as the current index to avoid using the same element twice. If both conditions are satisfied, we found our solution. We return a vector containing the current index I and the complement's index nummap complement. Finally, if no solution is found, we return an empty vector indicating the absence of a valid pair. This optimized solution has a time complexity of O times n, since both the hash table construction and the lookup operations have constant time complexity. Now let's move on to our final solution, which is a slight improvement over this one. Our third solution utilizes a hash table, but with a small modification. Let's take a look at the code. The solution combines the steps of building the hash table and finding the complement into a single loop. Let's examine the code more closely. As before, the TwoSum function is defined that takes in the vector nums and the target value. We create an unordered map called nummap to store the numbers and their indices. We calculate the size of the input array and store it in the variable n. The loop iterates over each element of nums. For each element, we calculate its complement using target minus nums of I and store it in the variable complement. Inside the loop, we check if the complement exists in the hash table using the count function. If it does, we found our solution. we return a vector containing the complement's index, nummap complement, and the current index I. If the complement is not found, we add the current number and its index to the hash table for future lookups. Finally, if no solution is found after processing all elements, we return an empty vector to indicate that the absence of a valid pair is that there's an absence of the valid pair. This solution maintains the time complexity of O times n while slightly reducing the code complexity. It combines the steps of constructing the hash table and finding the complement into a single loop. And there you have it. We've explored 3 different approaches to solve the TwoSum problem. From the brute force method to the optimized hash table solutions, each approach offers a different trade-off between time complexity and code complexity. It's important to choose the most suitable solution based on the requirements of your specific problems. If efficiency is crucial and the input size is large, the hash table solutions are your best bet. On the other hand, if the input size is small or the simplicity of the code is a priority, the brute force approach might suffice. If you guys found this video helpful or just enjoyed it in general, drop a like down below, subscribe for more, and drop a comment if you have any questions, and we'll catch you in the next one.